So we're going to start with page 40, question 2. Question says, the vitamin content in two foods, X and Y, is shown in the table with units in kilograms. A blend of foods X and Y is to be made which must contain at least 8 units of vitamin B and 30 units of vitamin D. Food X costs $2 a kilogram and food Y costs $3 per kilogram. Okay. So what's our goal? A, find the minimum cost mixture of X and Y which satisfies the constraints. The minimum cost mixture. What would be the minimum cost mixture for this? Anything else? So this feasible region is going to be a bit different, isn't it, compared to what we've done before? Maybe you can start to picture. Most of our questions that we've been dealing with so far have been in terms of maximising. But do you think if you're trying to work out a food, you're wanting to try and maximise something, or maybe you're trying to minimise your costs? Maybe we're trying to minimise our money. So have a look at what's the key information that we need to use to be able to determine the minimum cost mixture. What is that question asking us to do? It's like we're trying to work out how much of bag X should we use and how much of bag Y should we use. What's that, sorry?
At least 8 units.
So that's our key information. We know that we need to have at least 8 units of vitamin B and 30 units of vitamin D. We know we need to have that. But we're trying to solve how many of bag X food X should we have and how much of food Y. Basically, that question is actually asking us to do the entire linear programming process. But so far in the booklet, a lot of your questions have staggered you out. So we're going to need to do the whole process. So we need to start this process by first identifying our constraints. Lowercase x, lowercase y. Let x, let y. What should we let our x and our y represent? Food y. Let's try first with food x and food y. So let's go let x represent number of kilograms of food X. And should we let Y represent the number of kilograms of food Y? Let's try that. Once we determined our variables, what was our next step that we did in the process?
The lines.
The lines. Before we did the lines, we normally did something else. Starts with
greater than.
But even before that.
We did the plus X.
X and Y. There's a two-word name for it. Objective function. Good. What's our objective function? Our objective function is what we need to maximize or minimize. What are we trying to do here? Are we maximizing or are we minimizing? We're trying to minimize. So we're going to need to minimize. And what's the information about how much food X costs and how much food Y costs? $2 and $3. Would you minus if you're paying for something and you've got to pay for a certain number of this product and a certain number of this product? Does the cashier minus them? No, they plus them. So the objective function is 2x plus 3y because it's $2 for food X, $3 for food Y. We're on page 40 of our textbook. Yeah. We're doing this question here, page 40, question 2. What did we do after we made our objective function? The greater than or less than. We need to come up with our constraints. Okay. What were our default constraints that we normally started with? The 0. Yeah. In this case, is x going to be greater than or equal to 0? You're buying a food product. Yes, it's still going to be positive, isn't it? Constraints. X is greater than or equal to 0. And y is going to be greater than or equal to 0 as well, isn't it? What about our other two constraints? So over there it says we've got vitamin B, food X. Vitamin B is 1 and 4. So see our little table? We could always copy down our little table, remember? Food. Now, there's a bit missing there. What have normally we've had in our table? At most. We've had at most. In this case, is it going to be at most, or is it going to be something different?
At least.
It's going to be at least, isn't it? So should we add our row of at least? Where's our row going to go? Is it going to go there?
Underneath.
Underneath. Should we try underneath? All right. At least. All right. How much vitamin B do we want? 8. 8 and 30. Quite. Vitamin B, vitamin D. Where do we often get our vitamin D from? From the sun, yeah. So that's that tipping point between like getting sun but not getting burnt. So getting some sun's good. Okay. So we've got 2 more constraints that we can build, can't we? Work with the person next to you, and I want you to write down by working with the person next to you what the final 2 constraints are. Here we go.
It faces the big, I forgot what it's called.
A. So 8 is
The flank faces
so
the
it would be
But then it's a
greater than or equal to 8.
Is it greater than or less than?
Because if 8
At
is
least.
so it has to be at
At
least.
least.
So 8 is minimum, so therefore
It's greater.
1x plus 4y is greater than or equal to
I
8.
think you got it. All right. Someone in the front row's got it. Final 2 constraints. Joaquin, did your team get one?
1x plus 4y is equal than and greater than x.
Good. I'm just going to write x. Even though you said 1x, just to save you time. Thank you. Cam, did you get another one?
Yeah.
Yep.
We got, so we did the other way, so we got like a 30, so
Okay.
30 is less than or equal to 6x plus 6y.
Then what way have we been doing it?
So you've done 30 is less than or equal to.
I was doing all my arrows the wrong area.
You're right. You're right. I'm going to write it the other way around. Just that's my preference is to write it the other way around. Because we can. But you are right as well. Okay. Okay. We've got that. What's our next step? We need to graph it. Okay, so we need to graph it. How do we graph these types of equations?
I'm gonna find out.
What do we find? What's the
X, Y, and Z.
We've got to find the x and y intercepts. Okay, Elijah, you're in charge of finding the x-intercept for this first equation. Joaquin, you're in charge of finding the y-intercept for this equation. The red one. Up the front, Beck, you're in charge of finding the x-intercept for the starred one. Great. And we need one last volunteer.
They're both 5.
Volunteer. You can be in charge of finding the blind intercept. Yeah.
Let me do my job too.
Why do that when you get? Actually, I'm not going to start sketching my graph yet because we don't start sketching our graph until we know what points we've got to put on.
Yeah.
75.
All right. EB. What did you get? 8 is the x-intercepts, correct? Because cover that. Joaquin, were you doing the y-intercept?
Yes.
What'd you get?
2.
2. You're right. Sorry, I don't know why that comes up.
How
It's
is
a touch screen.
rolling?
It's because maybe there's an actual touch screen that's actually there.
Touchscreen, yeah.
Oh, see that? Oh yeah.
Oh.
But I'm just going to close that down somehow. Yeah, so it's sort of like, I think it's this. I reckon it's that there. That's a sensor.
That's so cool.
All right. For this bottom one here, Beck was doing our x-intercept.
5.
Yeah, right. And
5.
5.
Well done.
All right. So now we're ready to sketch it, aren't we? These people got the graph going.
I think I actually understand.
Oh, that's exciting.
Very much worse than this.
Oh my god.
We're doing that one.
Yep. That's why my plan today is for us to do 2, hey? How's that? Is that good?
Yes.
2. Now, things that you get marked on in your test. Have you labelled your x-axis and your y-axis as x and y?
Yes.
Have you labelled them in words?
Yes.
No.
Food, x. Kilograms. Food, y, kilograms. You got that? Now we need to draw the graphs. 8, 2, and then join them together. And 5 and 5. That is. Okay. And normally we then shade the feasible region. I'm going to shade it in red. All right. Greater than, greater than, greater than, greater than. So it's all above it.
It's all outside the line.
So it's above this line, it's above this line, it's above this line, it's above this line. So it's all of this. I would be understanding if you had shaded this little quadrilateral little shape in the corner, because all of us so far that we've been doing have been minimizing. It's that whole. That's all being maximized. Yeah. This is a single. Yeah. So we're kind of on track for finishing because I wanted to do 2 questions. We've got 40 minutes. We've got 20 minutes left. All right. So what do we do next?
Now it's
You mark the intercept.
You mark the intercepts. Good. Yeah.
Sarah, would we set this?
There's only really 3, isn't there? There's that point there, which is 4 and 1. There's that point there, which is,
0.
and there's this one here, which is. So there's only 3 vertexes, because this way they go on forever. So then what do we normally do?
The table.
The little table.
What table?
Vertex.
The table.
We write down what our 3 vertexes are.
I don't even know, man. I couldn't tell you the difference.
Again, this is what we would call in general maths a complex problem, because it hasn't given you the steps to do it. Okay? In your test, you're going to have a mix of routine and complex problems. Some will guide you through it step by step. Some will be a bit more open-ended.
So
Okay?
the questions in the test will be easier or harder than this one.
Yeah. Or about
This is
that.
probably like an extent of a hard question at this point.
Okay, so there aren't going to be
Oh,
any
okay.
hard.
We're doing the top ends today. Yeah.
Okay, alright.
Oh, with it.
Probably the next question that we're doing today, Sam, is probably one of the more difficult ones, actually.
So that's probably as hard as the test.
Yeah. Okay, what do we do with the vertexes? What do we substitute them into?
The 2x plus 3y.
Value of the objective function, 2x plus 3y.
Wait, how did we get that? That's what I did.
Okay, we got this because it costs $2 to buy food X and $3 to buy food Y. Okay. You know, the objective function is often to do with money, or it might be to do with like an athlete wants a certain amount of vitamins or something like that. Like that, you know, it's something to do with that. It's whatever you're trying to minimize or maximize.
Nutritional value.
Nutritional value, great terminology. Okay, we substituted in here. I got 11,
Oh, wait.
16. Did you get those three answers?
Yeah.
So which one is our objective function? The optimal
Eight
solution.
to 0.
Sorry.
Oh, 4 and 1.
What's the optimal solution?
4.
Okay, optimal, that's because that is the minimum. So that's the optimal solution. So therefore, we're still on A. Should buy 4 bag, no, what's it called, food X? 4 kilograms of food X and 1 kilogram of food Y. What is the next question asking us to do? Discuss the vitamin content of the optimal mixture.
Wait, question 2D what?
Question 2b says, discuss the vitamin content of the optimal mixture.
Thank you.
What does it mean by the vitamin content? What, have we been given any information about the vitamin content?
Not really.
Yes, we have in that green table. Check it out. We know that for every bag of bag X, you're going to get 1 unit of vitamin B and 6 units of vitamin D. So this question is going, can you use that information in the question? So it's a bit different type of question. I'm just going to erase the left of the board. So because we know that food X has 1 unit of vitamin D and 6 units of vitamin D, how much vitamin B will you have? Well, you'd have 1 unit for every kilogram of bag X. So 4 times 1 plus, you get 4 units for every bag of bag Y. So 4 times plus 1 times 4. So you can't quite see where we got that from yet.
No.
From this table.
Yeah, I see the table.
Because we're buying, as we are recommending 4 kilos of food X and 1 kilogram of food Y, that's how much vitamin B you're going to have. And vitamin D, how do we do the vitamin D calculation? Is it 6 and 6? You get 6 units for every. So you got 4 kilograms times 6 plus 1 kilogram times 6 units as well, which is 30 units. Alright.
Which is
It's already given in the tape, yeah. So, again, sometimes in general maths there might be a question to see can you actually use that solution given the information as well. Yeah? Alright, should we go on to our next question? Page 44 is our next question. Question 1. Yeah, this one's non-integer. Yeah. Can I erase the left-hand side of the board now?
Yes.
I hate writing on the left hand page. Sorry, I'm not. Yes, I know. Big bucky.
Alright, here we go. We've got fertilizers. Fertilizers X and Y. Can you read out for us the information?
Yeah. Which question? Sorry.
Page 44, question 1.
Oh, okay. Fertilizers X and Y contain ingredients A, B, and C in quantities shown in the table in units per kilogram. Fertilizer X costs $8 per kilogram, and fertilizer Y costs $12 per kilogram. A farmer needs a mixture of fertilizers containing at least 25 units of A, 38 units of B, and 16 units of C.
And the question is, A?
What combination of X and Y should the farmer use to minimize costs, and what is the minimum cost?
Alright, so we're trying to minimize here again. Because a farmer, my brother-in-law's a farmer up the York Peninsula, he always wants to minimize his cost and maximize his profit. Okay? He uses fertilizer all the time. Okay, what's our X and Y? The fertilizer X, kilograms of fertilizer X and Y equal kilograms. Because we've got about 12 minutes left, I'm just going to fly through this, okay? But I've got it on record, and there'll be a visual there as well. We do that, we then do our objective function. What's our objective function? We want to minimize 8x plus 12y. Because it's $8 and $12. We then do our constraints. If we're using fertilizer, can we only use a positive amount of fertilizer? Yes. And we haven't been told that there's like a limit, maybe the supplier only has 1 million kilograms of a certain fertilizer. We're not told that. So we know that X has to be greater than 0 and Y has to be greater than 0. And we're also given that little table of info, aren't we? But we're missing the bottom row, which is like at most or at least. Can we fill in the bottom row? What is it? Is it at most or is it at least? It's at least because we're told he needs. Hang on, I just said he, but do we know that it's a he? She? Doesn't matter. This farmer needs.
Oh no, it says he down the bottom. In part B.
Doesn't matter really. It's irrelevant. What is it? Is it 38? No, 25. 38 and 16. Happy with that? Can we now come up with 3 more constraints?
2x plus 4y greater than
2x plus 4y is greater than or equal to 25.
Wait.
I can wait.
Yeah, okay.
You right? What's our second constraint?
5x plus 3y is greater than or equal to 38.
Good.
So,
And our last one?
It's gonna be one x, so just x
Yep.
plus 3y
Is
equal to less than or greater than
which one?
16.
It's going to be less than or greater than?
Greater than?
At least. Yeah, so greater than or equal to 16. What do we do next?
Find the
Intercepts.
Find,
X and Y.
we need to find the x and y intercepts. Okay, let's do some x and y intercepts.
first one,
First one?
x intercepts 12.5.
Go
Y
on.
intercept is 6.25. Next one, x intercept is 7.6. And the y intercept is 12.6 recurring. And the next one, x is 16. And then y is 5.3 recurring.
Yikes. Okay, so we've got some decimals here. Okay?
Oh,
Well, I just like, oh. So
Okay, now we have to graph it.
we can do this. We've got to graph it now. What's our graph going to go up to? I can see 16 is the maximum for x, and the maximum for y is about the same. So I'm going to go 16, 16. Just to, that's what I'm going to do. My units are different just because of the way I've set up my graph. You can see my x-axis is one box, but my y-axis is one box represents 2. That's okay. Okay. So we got 12.5, which is there, and 6.25. We're going to need to be as accurate as we can, even though we're sketching by hand. Why do we need to be as accurate as we
So
can?
we can find the intercept.
Yeah, so we can find the intercepts.
We can still do that on the calculator, can't we?
Yes, and that's actually what I'd recommend.
We'll be doing it by hand.
So we're going to sketch it by hand, but to find the intercepts, you could plug those 2 lines into the equation solver and it will tell you the point really nicely. I'm going to actually now go,
What's the next one?
so the next one is 7.6 and 12.6.
I
Okay. So,
Is there 3 on there?
well, we really need to find where these points of intersection are, and it looks like there's a few points. To me, when I look at this, it looks like there's a point of intersection there, and it looks like there's a point of intersection there. Remembering that our feasible region is our feasible region up the top or down the bottom for this question? It's up the top because it's greater than. Here's our feasible region. Okay. How do we find these intercepts when they're so hard to read off the graph? You could plug this into your graph mode, but plugging into your graph mode means we need to rearrange some things. I want you to first have a look at this red dot that I'm putting there. Watch this. That red dot, so the key question is how do we find that point of intersection? That red dot is where these two lines meet, 2x plus 4y and x plus 3y. Which are these two over here, isn't it? That point and that point. Is there a nice way we can solve the point of intersection of those two equations? There is. What's the way, Sam? Equation solver. So if on your graphics calculator, you just
Is that 5.5 and 3.5?
plug those 2 points. Let's bring up our equation solver here. Simultaneous. I've heard 5.5 is being called out. To me, hey, 2. Yes, I got 5.5 and 3.5. So then you put that point there.
Oh, yeah.
Okay.
Yeah, that's
And then what two equations could you do to solve this point here?
the 5x plus 3.
The other two. Right, we're just going to put our pens down because our lesson is fast coming to an end. Your homework is to see how far you can get through that question. Alright?
Can you tell us how to do that intercept first?
How to do that intercept?
That one?
That one there. Well, what are the two lines? It's that line there, and it's
Top.
There's so many lines I got lost.
and it's the top line.
Yeah. Okay.
So you need to find what the two lines are and put them in equation mode.
Yeah.
Now, the question's going to go on, but tomorrow morning I'll be on the board the rest of it so that you can check it.
Okay.
But I think one of the best ways you could do some learning is to go away and give the question your best shot yourself and then actually see it and compare it.